Hello everyone. We have almost completed differentiation actually. Most of the types of differentiation we have done. Basic ones, by the way. We are now to do double differentiation. Okay, so single differentiation we have almost completed. I have come to few um, miscellaneous problem. Today I'm going to solve few mixed and miscellaneous problem. It can be from any of these any of the topics that we have done earlier. Okay, so the first one we have is find dy dx if y equals to log under root 2x plus under root 4x square plus a square. So how would you do it? So let's start. So differentiating both sides with respect to x. What do you get here? You get dy by dx, and that side ddx of log under root 2x plus under root 4x square plus a square. Correct? Okay, now dy by dx here, that side I think I'll get this ddx of log is 1 by x, isn't it? Ddx of log is 1 by x, so 1 by 2x plus under root 4x square plus a square. There's a lot of chain rule here. Into ddx of, now I have to do under root 2x plus under root 4x square plus a square. Check this out. Okay, a lot of chain rule. So what I have to do here is now 1 by under root 2x plus under root 4x square plus a square. That's done. Into what is ddx of root x? So consider everything is x. I have to think this is x. ddx of root x is 1 by 2 root 2x plus under root 4x square plus a square. Careful. So into, again chain, ddx of 2x plus under root 4x square plus a square. Did you see this, everyone? Okay, I have to create a chain. Now that I have done this, it will give me, let's multiply these two, this and this with the root, by the way. Okay, when I multiply these two, what do I get? 1 by 2 and root of the same thing. If it multiplies, then the root vanishes and you get this much. Correct? Okay, into this will be open bracket, ddx of 2x is 2 plus 1 by 2 root 4x square plus a square, and directly I'm going to do ddx of 4x square plus a square. I have to do the differentiation of the inside one, again chain, and that'll give me 8x, isn't it? So this cancels and 4. Correct? Okay, so that gives me 1 by 2x plus under root 4x square plus a square. Check this out. Into I can take out 2 common from here, and there will be 1 plus 2x by under root 4x square plus a square. Correct? So 2 and 2 gets cancelled finally. Correct? Okay, now let's take LCM here. Okay, we'll take LCM here. So what do you get? So let me do it here, somewhere here. 1 by there is no more 2 now, 2x plus under root 4x square plus a square, into the LCM is under root 4x square plus a square, and I suppose you will get under root 4x square plus a square plus 2x. Check this out from here. Am I correct? Yeah, the LCM is root 4x square plus a square, and that's correct, absolutely. Okay, so now I have 1 by 2x. Okay, why should I do that? So can I cancel these two? Yeah, this is cancelable. So the answer is 1 by under root 4x square plus a square. So finally, that's the value of dy by dx. Okay. Here I have the second one. It looks quite complicated, but it isn't that difficult, okay, as you see here. So look at the question itself. It says if y equals to e to the power x plus e to the power x plus e to the power x, and this continues till infinity, then you have to prove that dy dx is y divided by 1 minus y. Okay, indeed it's very a simple sum. So what happens is you have to think something like this. So how many e to the power x are here? How many e to the power x? So it's like this: e to the power x plus e to the power x plus e to the power x plus e to the power x, sorry, plus e to the power x plus e to the, so it goes on till infinity, isn't it, everyone? So it's like there is a you may say there is a big lake, okay, and there are how many e to the power x here? There are infinite number of e to the power x in this lake. From this infinite amount of e to the power x, if I take out 1 e to the power x, does it make any difference? That is something like saying from the ocean, if I if I remove a bucket of water, does it make any difference? So it doesn't, isn't it? Because even if I take out, remove 1 e to the power x, still there are infinite number of e to the power x here. Are you understanding? Let me repeat this. So there are, see this everyone, there are infinite number of e to the power x. Okay, like this, e to the power x plus 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 dot 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 infinite. Okay, so I don't know how many. So out of this, if I remove one of them, it doesn't make any difference. Okay, what will be the rest? Rest will still be y. Okay, so can I write it like this? How does this work is, have a look. I can write given y equals to e to the power x plus e to the power x plus dot 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 till infinity, isn't it? So I can write this as like this, y equals to e to the power x plus y. I can write. How do I know that? Because even if I remove 1 e to the power x from the rest, this will still be y. Isn't this still y? There are infinite number of e to the power x. Y is a expression which contains infinite number of e to the power x. Once I remove 1, still the leftover is y. Okay, so I will replace this by y. Now time to differentiate. So maybe you will take log, taking log both sides. I think that'll be better. Both sides. So what do you get? Log y equals to log e to the power x plus y, correct? That gives me log y equals to x plus y log e, and everyone knows log e means 1, so log y equals to x plus y, correct? So differentiate, differentiating both sides with respect to x. With respect to x, what do you get? You get 1 by y dy by dx, and here you'll get 1 plus dy by dx. Finally take it here, so 1 by y dy by dx minus dy by dx equals to 1, correct? So let me do this here. So dy by dx common, you get here 1 by y minus 1, and that side 1. So take LCM, here y, and you get 1 minus y. So that's dy by dx and 1. So flip it, cross multiply, sorry, y divided by 1 minus y. So that's the answer. That's what you're supposed to get. So only the basic simplification here is very important. Again, I'll repeat, maybe some of you haven't understood. So y is infinite number of e to the power x. Okay, out of that infinite number of e to the power x, what did I do? I removed 1 e to the power x. Okay, I removed this. What will be the remaining? The rest is still y. That's why I can write y equals to e to the power x plus y. Got it? After that, I simplified this. A very interesting sum actually, this one. Now I have a formula that we had missed out in logarithms. Not missed out actually. I told you that I will do this formula later. And this formula is indeed very important. It is called the change of base formula. What happens is, usually we write logarithms this way. Log, let's say, a to the base b, isn't it? So this is known as base, everyone, correct? And in in calculus, usually the base, when I write log x, the base is usually e, isn't it? So what happens is, this formula will teach you how to change the base. Let's say I have something like this, logarithm of a to the base b. Okay, and suppose if I want to change this base, if I want to change this highlighted base and want to make this base b as something else, let's say c, I want to make this base as c. So then how does it work? The formula says you just have to simply write log of a to the base c. Got it? Okay, check this out. So there was a log of here it was log a base b, here I'm simply writing log a base c, isn't it? But in order to neutralize this, what you have to do is you have to write log of previous base, that is b, to the new base c. Okay, so remember this formula. I will okay, I'll just check this out, everyone. I'll just rub this out here so that you understand. Okay, check this out. So this is the formula, everyone. So I will rewrite it again if you haven't understood. This is what you have to copy, not this side, change of base formula. I want you to copy this. So let me give you an example. Let's say if you have log of let's say log of how much x base 2, just an example. Okay, then how to make this base 2 to base 10, let's say, then you have to do log of x base 10, that's normal, divided by the previous base. Log of what was the previous base? 2 and new base, that's 10 to neutralize this. Okay, so first simply change 2 to 10 and then do this neutralizing part. Okay, that means you just have to write log 2 base 10, previous base to the new base. Got it? Okay, so this is the formula. We call it as the change of base formula. Okay, so pause the video and copy this highlighted one, copy this formula. Okay, let me rub this now, and then I will do a sum based on this. Okay, a differentiation sum. The sum is like this. Find dy by dx if y equals to log of cot x to the base tan x. Correct? So this is the sum that we have to differentiate. So how would you differentiate? I cannot differentiate this until and unless I change the base, because ddx of log x formula is how much, everyone? 1 by x. Here the base is e. In logarithm formula, in the standard derivative, whenever you are using logarithm formula, the base is e, not any other base. But here the base is tan x. So what I have to do is I have to change this base to the normal base, that is e. Okay, so let's change it. So I'll make it log of cot x and the new base, that's e, and I'll write here log of old base to the new base. Correct? That's how it is done. Now let's differentiate. I'll write log, no need to write e now, log cot x divided by log tan x. Can I do that, everyone? Yes, that's equals to y. Now can I write it like this, something like this? Let me show you here. Y equals to log of, what is cot x? 1 by tan x, and here it is log tan x. Correct? Okay, then what can I do here is y equals to log 1 minus log tan x divided by log tan x. Can I do that? Yes. How is it possible? Because log a by b is log a minus log b. You know that formula, the quotient rule. Okay, now can I do like this? Log 1 means how much, everyone? Log 1 means 0, so no need to write. So minus log tan x divided by log tan x. So cancel, so y equals to minus 1. So differentiate, what will be dy dx will be 0. Very simple answer. So until and unless I convert this to e base, I could not have solved this sum. So this is how we apply the change of base formula in differentiation to differentiate it. If you ever get logarithm sum with any other base, then make sure you use the change of base formula, convert it to e, only then you have to differentiate it.